Let's start with the simplest text-to-video generation feature. For this demonstration, I'll be using the Wan 2.2 model, currently the one offering the best video quality, and load its text-to-video workflow. The overall process for text-to-video with different models is largely the same, typically including model loading, optional generation optimization steps, setting resolution and FPS, inputting prompts, specific sampling and scheduling, and finally video synthesis and saving. Let's walk through this workflow in detail. Similar to the text-to-image process, model loading generally involves three main components: the base model, the text encoder, and the VAA. Wan 2.2 is slightly unique in that it provides two versions of the base model, high noise and low noise. The high noise model focuses more on motion, while the low noise model enhances detail. Both are used during the sampling process. Since video generation models are typically large in size, consumer-grade GPUs often struggle to run the official BF16 or FP32 versions directly. Therefore, quantized model formats are needed to reduce VRAM requirements. Here are some options. The simplest and most common option is FP8, which uses the same loading node as the original model. The E5M2 format offers better compatibility with most GPUs, while the E4M3FN format provides better quality. Alternatively, you can install the ComfyUI GGUF plugin to load models in GGUF format. This allows you to select an appropriate quantization level according to your available VRAM, ranging from the smallest Q2 up to Q8. Nunchaku is another quantization solution that requires the ComfyUI Nunchaku plugin. It offers Int4 and FP4 model formats. FP4 is optimized specifically for RTX 50 series GPUs. These are not only small in size but also provide fast inference speeds. However, model conversion and release progress is relatively slow, and new models may take a long time to become available. In addition to official models, the community has also released many variants fine-tuned from the base models. For example, Fusion X, tuned from Wan 2.1, can produce more cinematic results. In this workflow, I'm using the Wan 2.2 GGUF Q6K high and low noise model. Different models also require their corresponding text encoders. For example, Wan 2.2 uses UMT5XXS, while Hunyuan Video 1.5 uses Q1 2.5 VL. Modern text encoders are quite large, so here I'm using a halved-size FP8 quantized version. Note that you must select the encoder type that matches your model in the node. If VRAM is tight, you can set the device to CPU. The VAA must also be compatible with the model. Otherwise, errors or noisy video will result. Compared to the base model and text encoder, VAA is much smaller and generally does not have a quantized version. Models usually have recommended resolutions. For instance, Wan 2.1 even released two variants dedicated to generating 480p and 720p outputs. Wan 2.2 is less restrictive with output size, but for optimal results, it's still recommended to keep within the suggested range. Here I'm using 480 by 832, a classic 480p vertical resolution. Frame count is another critical parameter. I recommend generating whole or half-second videos based on the model's FPS. Take Wan 2.2, it outputs at 16 FPS, so you should set your total frames to 8 and Fos 1. In other words, multiples of 8 plus 1. It's best to keep the range between 33 frames for 2 seconds and 161 frames for 10 seconds. Otherwise, you may get static frames, mirroring effects, or visual artifacts. Most models use 16 FPS, so this rule applies, but there are exceptions. For instance, early SVD requires exactly 14 or 25 frames. Hunyuan Video 1.5 outputs at 24 FPS and, by default, generates 121 frames for a 5-second video. For demonstration, I am using the minimum, 33 frames. Note that frame count affects the entire generation process. It's not just about stretching on the timeline. Changing the frame count will alter how the model interprets motion timing, composition, and background details. If you want to draw a lottery with a quick 33-frame short video, and then use the same seed and parameters to generate a longer 81-frame video, you'll often get significantly different results. For most models, positive prompts are the core parameter in video generation. With Wan 2.2, for example, you can construct prompts using this formula: subject, environment, action, aesthetic controls, and style. Different models use roughly the same formula for prompts in text-to-video. Always try to provide as much detail as possible for the subject, environment, and action. For example, Hunyuan Video 1.5's official prompt formula follows the same logic. In practice, you can supply these formulas and sample prompts to an LLM to automatically expand them for richer descriptions. or use custom nodes such as the various prompt generation nodes from Me nodes to automatically generate or optimize prompts. As text encoder capabilities have improved significantly, you can now directly use Chinese prompts in most cases. Specifically with models like Wan and Hunyan Video, Chinese prompts often better capture Asian facial and body features. For most video generation models, negative prompts are not critical. For example, Wan 2.2's default negative prompts focus on quality-related terms and usually don't require modification. Hunyan Video 1.5's official inference script doesn't use negative prompts at all. Especially when using acceleration solutions like LightX2V, where save fee must be set to 1, negative prompts are basically not applied. Because video generation is resource and time intensive, many acceleration and optimization solutions exist. Most are compatible and can be used together. In this workflow, we've loaded the LightX2V LoRA model, which reduces sampling steps to 4 or 6 while maintaining quality close to the original model's 20 steps. This massively reduces sampling time. Sage attention is also enabled. This is an advanced attention quantization optimization that significantly speeds up attention computation, but requires Triton and Sage attention dependencies in your ComfyUI environment. Finally, we enable Torch's FP16 accumulation option through this node for further performance gains. You can also use caching technologies to skip parts of the sampling calculation. Popular options are TeaCache and ComfyUI's built-in EasyCache, both of which offer algorithms for skipping similar frames. Beyond pure acceleration, you can stack plugins for enhancing quality or stability, such as loading dedicated quality-enhancing lower ORAs, or using post-processing plugins like Enhance a Video for de-jittering, detail enhancement, or frame interpolation. It is important to note that in my experience, speed and quality are hard to balance. Gains in generation speed almost always come at the expense of quality, and vice versa. It's up to you to choose a combination of solutions that best balances speed and fidelity. In this demo, I only enabled LightX2V. As with the image generation workflow described earlier, the core of the video generation process is the sampling stage. Although Wan 2.2 is a bit special in that it uses 2 sampler nodes to execute a 2-stage sampling process, the high noise model for composition and motion planning, the low noise model for detail refinement, most parameters are the same as in other video generation models. In the model sampling node, the shift parameter has little impact and can usually be left at its default. The seed, just like in image generation, controls randomness and is useful for drawing a lottery. With LightX2V acceleration enabled, save fee should be set to 1 and total sampling steps can be reduced to 4, the first 2 steps handled by the high noise model and the last 2 by the low noise model. For the sampling method and scheduler, Euler plus Simple is a safe and robust combination that works for almost all models. Some specific models or scenarios might have better combos, but differences are small. For example, Wan 2.1 can use un epic plus TED-GEM uniform. The last part is for image decoding and video saving. We can use the built-in Create Video and Save Video native nodes in ComfyUI to generate videos, but I recommend installing the plugin ComfyUI Video Helper Suite. With this plugin, you can utilize the Video Combine node, which offers more options and supports exporting to various formats such as GIF, YBP, H.64 MP4, and GBM. Please note that the FPS should be set to the value recommended by the model. Click Run. With the acceleration provided by the model, it took just over a minute to generate the video. The resulting video shows the young lady's posture and drinking movement as very natural, with a warm smile and strong affinity. The sunlight and shallow depth of field give the image both warmth and a sense of depth. As previously mentioned, Wan 2.2 supports Chinese prompts. If you use equivalent Chinese prompts in this workflow, the result will be similar to the one above. See if you notice any difference in the output quality. In this process, we used Wan 2.2. If you switch to Wan 2.1, Hunyan Video 1.5, or LightX2V, the workflow remains the same. Model loading, optional generation optimization steps, setting resolution and frames, entering prompts, specific sampling and scheduling, and finally, video composition and saving. 6 main steps in total. Only the prompts and some parameters differ slightly between models.